Hello and welcome back to AGT STEM. Today we're going to be watching a video about silver. So, without further ado, let's hop to it.
So our reaction's ready. Now all we need again is a little bit of water just to start it off. So we're here today and we've come back after hours because we need to use this room for a long period of time. Because we're going to do something quite exciting. Because Brady's brought another camera, which you can see set up over there. And we're going to use that second camera to capture 1 second of film every minute for maybe 2 or 3 hours. And we're going to do some time lapse. Something I've seen on TV with like flowers opening or plants growing, but never with chemistry developing.
Silver is one of the few metallic elements that occurs naturally as the metal in nature. So that if you're lucky, you can wander around and find lumps of silver lying around on the ground. And this is how, in ancient times, silver...
That's pretty cool. I wonder why, like, other types of metal don't actually show up as metal in nature.
...was discovered. So it has been known for thousands, if not tens of thousands of years. Gold is somewhat similar, and also copper. But most other metals combine too easily with oxygen or other elements. So you don't find them naturally.
So I thought what we do today is to do a competition reaction. And that competition reaction is based on something called the reactivity series of metals. So we're going to compare the reactivity of two metals. It's a bit like a game of football. We're going to give one of those metals the football, and in this case it's another component or another salt component, nitrate. So the two metals that are going to be competing for the nitrate are silver and copper. And really, these are related by something called the reactivity series. One of these metals is going to win. I know that, and I hope we'll find it during this video.
Silver had a particular use in photography. And in the old days, when people used photographic film, the black colour that you saw on developed negatives is in fact silver. A photographic film consists of a layer of silver bromide or sometimes silver iodide, and when the light shines on it, the light just starts a tiny amount of reaction making silver, and then when you put it in the developing solution, the catalytic amount of silver that you've produced causes a big reaction and you make a large amount of silver. And so you get this black colour, which then you can print as pictures.
So on the bench, I've got a small beaker or an Erlenmeyer flask, as we chemists call it, which is full of deionized water. So we've passed the water through a machine, which has taken out all of the other ions so that they can't sort of play around with the competition reaction that we want to start today. Firstly, I'm going to start off by giving the prize of the competition to silver. So here I've got a sample of silver nitrate. It's sensitive to light, so I can't leave it out in the bench very often. So now what I want to do is I'm going to put some into the water to make a silver nitrate solution. So I want to make sure there's plenty in there so that it's saturated. Now we've got to put in the competitor. So what we're going to do is we're going to take some copper metal. And this is just a sample of wire, which I've rubbed with some wire wool just to make it sort of nice and shiny. And now what I'm going to do is dangle it into the silver nitrate. Then it's going to start.
I think it's pretty crazy that it's so simple. All you have to do is take these two solutions and then just put a stick of copper in it.
Compete for the nitrate, and we'll see what happens. So Brady started the recording, and I think the best thing for us to do is to go away and do something a little bit more exciting and come back and have a look in an hour.
Silver has become quite popular recently as a potential new way of making things antibacterial, killing bacteria.
So now we're going to make some flash powder, and the flash powder that we're going to make today is just a 2-component mixture. It's very finely ground magnesium, and the second component is it's ground silver nitrate, solid. Okay, so we take these two components and we mix the two together very intimately, and Neil's just weighing the materials out right now. So we're going to put the magnesium and the silver nitrate, the two powders, together into a small plastic container here. We're going to mix them very, very carefully, and then we're going to see what happens when we sort of initiate a chemical reaction.
For hundreds of years, people have used silver spoons, partly, I think, because silver is quite easy to make, but also because the silver does have properties that kill bacteria. So a silver spoon was less likely to get harmful bacteria on it than if you have one that's made out of wood.
That's pretty interesting. I didn't know that. So apparently silver has like bacteria killing stuff on it or in it.
Or horn of a cow or something like that.
So we're mixing these very carefully in the fume hood, just in case the chemistry starts before we want it to.
And in recent times, people have started making very, very fine particles of silver, so-called nanoparticles, which can exist in solution. So here I've got a solution of silver nanoparticles. You can see it doesn't look silver, it looks a bit yellow actually. And you can tell that it's got particles in it because if I can find a torch. So here we've got particles, and you can see the particles better if we shine light through it. And if you look at the light, you can see that there is a cone of light that looks rather like the headlights of a car in fog. And this is an effect that is called a Tyndall cone, which indicates that they're very, very tiny particles suspended in the solution. So this is not silver dissolved in the water, but actually very tiny particles.
So let's start the reaction just with a little bit of water. Wow, I think we should do it again though.
Just a little tiny bit of water and we've got that big of a woo. That's crazy.
Yeah.
People are now using these silver nanoparticles for all sorts of purposes. Here you can see that they've been put onto some sort of plastic, and you can now buy socks which have silver nanoparticles on them, which are claimed to kill the bacteria that make your feet smell.
So we're going to repeat the reaction. That's going to come out somewhere, isn't it?
Silver will conduct electricity. It will also conduct heat. If you've ever tried stirring tea with a silver spoon, it gets very hot. You tend to drop it. It also conducts electricity well.
So we're going to repeat the reaction so that you can see it again, because that was really fast. This time we're going to do it on a glass dish so you can see it a bit better. And we'll pour out a small amount. So our reaction's ready. Now all we need again is a little bit of water just to start it off.
Did you catch that?
I managed to close my eyes this time.
During the Second World War, when the US government was involved in enriching uranium as part of the Manhattan Project, they needed an enormous amount of wire to make magnets. And so a huge amount of silver was taken from the US Treasury, where it was stored as silver to give value to the US dollar, and was turned into wires to make magnets. And I believe that the silver was never returned, or at least it wasn't returned at the end of the war as was promised.
Well, I've managed to film maybe 1 minute's worth of time by now. Maybe 2, because we've been away about 2 hours. So we're going to go back and have a look at the flask, see if there's any changes. If you remember when we left, it was a nice clear solution of silver nitrate with some copper wire, which was just immersed inside. So let's go and have a look. There's been big changes in our flask.
Wow.
So if you look carefully, you can see now that the copper
It looks kind of like a fuzzy chicken foot.
wire itself is covered in very, very sharp crystals of silver, which have basically become deposited on the surface. Copper has now won this chemical reaction. It's now going into solution. It's taking the salt element and precipitating solid silver crystals. So if you look carefully, you can see that the colour of the solution has changed. It was colourless. Now it's blue, which tells me that there's another ion, copper, in solution.
Well, that's silver. Thank you so much for watching, and we'll see you next time. Stay smart. Bye!